Cool. Thank you, everybody. We're going to get started now. Cool. So I want everybody to give a round of applause, and let's give it up for our next speaker, Zoran Ivanovic. Okay, Zoran is an application and data principal consultant with AWS Professional Services in Canada. After 5 years of experience leading forecasting platform team in Amazon, he moved to AWS to share his experience with larger enterprise customers who are interested in leveraging AWS services to build their mission-critical systems in the cloud. And he's going to talk about solving data problems unconventionally.
Before we do that, let's turn that off because it's facing the audience.
Oh, yeah.
I don't know how you do this.
Thank you. Okay, I think we will finish. Where's my watch? By midnight, I think we'll be. Thanks for the great presentation. I'll be very honest. I'm a long time in the industry, so I couldn't care less anymore what people think about this or that, or my opinions. But I didn't understand a lot of things because it's all new technology to me. But well done, and I will go and Google after that one and hopefully learn a little bit more. Okay, so what I'll do here is I really wanted to show you. You mentioned on your slide first principles, and you talk about fundamentals. So I'll talk a little bit about fundamentals. I will talk to you how you should be very careful when you pick up your tools. And there's so many of those. And those tools, by the way, exist for 2 years, and after they die, and after you have to learn something else, and after you get really discouraged after many iterations of that one. If you're good with the principles, you will be always happy. You can always solve your problems. So we'll talk about that one. I'll give you some really large-scale examples which I was involved. And there's some of my colleagues here which are sitting there humble. They worked with me on some of those big problems. So let's have fun. I'm assuming I have to press some button. Technology, you know. Sorry.
Oh, no.
Two of us.
Yeah, there's two of us here. Okay, there we go. Just
Okay,
the arrows.
Yeah, so I did translate. Okay, so quick introduction. I used to be leading people. In the last 6-7 years, I only design and code. I code 12 hours per day. So what I'm not telling you here, I'm actually telling you reality. This is what I live and breathe. So there's no hidden things. It is exactly as I see it. So that's what I will be sharing with you. If you're happy how you do things in the data space, if things work for you well, excellent. Continue to do what you're doing. But I will tell you there is lots of more outside there for you to potentially learn, experience, acquire new skills, and be potentially way more competitive on the market. Here's one example. So while I'm talking my 3 tips for you, you can think about this problem. So the problem is we got huge, big manufacturer in the US. They wanted to give you APIs to tell you how much fuel was used by the machinery. Now there is 10 million pieces worldwide. Dealers might have 1 to 10,000 those machinery, and the dealer basically want to have an API to that manufacturer and say how much fuel I use between any period of time. So there is nothing given, per week or per month. No, it could be any number of days arbitrary in your data calendar during in the last 5 years. So what we had over 1.2 billion of data records, and SLA was about 50 to 100 milliseconds. So if you have 100 machinery you're asking for, 50 milliseconds is good. For more, 100 milliseconds was acceptable. So that's something that you can think about that while I'm talking about other stuff. Okay, so one of the things which I learned through my days in Amazon and before Amazon, and the people which are sitting there, they know very well This is the really important for you. You have to go back what you learn in school. Please don't forget what you learn. This is the most important thing in your life. If you forget, you're really taking from your paycheck in the future. So really stay very recent with what's the OS, how memory works, what's the CPU, what's the core, what's the context switching. That's really important for you. And everything else which I'm saying here. This is why Amazon is one of the top tech companies. This is why Google is one of the tech companies, and so forth. Because they really spend time hiring people which are really good in these things. My colleagues behind as well, they're really good in these things. So I don't want to spend more time on it. This is really important for you to know. You have to know data structures, you have to know what's caching, you have to know what's queuing, you have to know what's streaming, what's the difference between messaging point to point, pub sub, different architecture models here, event-driven architecture. Those are really important part. BGO. How many of you know what's BGO? Okay, few. Yuri. Yeah, so how fast your algorithm is working, or your model, or your piece of code, how fast it's performing. This is what BGO is giving you, that type of information, so really important for us. Now, I can spend hours talking about philosophy, about how amazing is this language versus that language, and those principles, and so forth. The one problem, and I, by the way, know quite few cutting-edge technologies in the Silicon Valley, and I tell you, they need speed, and speed, and the speed. And the language which potentially using today, it won't give you that speed. And the potential knowledge which you have today, it won't give you that speed. So if you want to be on the top, on the cutting edge, go back to those first principles, learn them again, relearn them again, practice them, and try to get those type of jobs and those type of projects to really hone your skills and the knowledge. Hopefully this is very clear. One thing I have to mention, you're going to say, okay, I pick my language, it's easy to learn, it's easy to use, it's data, who cares that much? You're so wrong. Everything is about data. And it's so much difference if you do something in 1 hour. You gave excellent example. Is it 21 hour or 2 hours or 1 hour or 15 minutes? You know how much energy you burn because you're wasting that extra hours? Nobody counts that today. Mark my words, in a few years, they will mark. They will grade you. There will be some type of green, some sticker or something which tell you your process pass or fail. There will be quota in the future. Like from the flying, it will be for your process how fast it's executing and how many CPU cycles is burning. I know it looks scary for some of you, it's going there. There's no discussion. So, you might not like your Python process today. Tomorrow it must be Rust. What language you pick? I'm just making up here. So, yeah, scary times are coming. Anyway, I don't wanna go there. Few books. Those are really on the left side. Of course, is the one which everybody in the pretty much computer science departments are using. You can use any of the other ones to kind of refresh your knowledge. There's a little bit more practical. The first one is more academic. This will be more practical side. If you want some of the refreshment of your knowledge and skills, go with the Harvard. This is really excellent done by David Malm. I don't know if anybody of you watch his YouTube videos. Top notch. So go and listen to those. You can just type, just remember Harvard CS50, that's it. And it's good enough, you will find it. It's everywhere. The other thing, I know this might be heavily data people and data group, and I know that some of you, and I met quite a few in my life in the industry, people really stay away from too much coding, and it's a little bit scripting, and I want to use tools, so I want to avoid any coding, and if I can use ChatGPT and avoid coding, I will stick with that one. If you want to really do well in this industry, I will tell you, go back again and have a look at your programming language of choice, whatever it is. Be really good at that. Don't be half. Really go deep. This is, I know probably half of you say, I have no idea what he's talking about. This is really a really important part. If you want to make money in future in this career, first, number one, which I talk about fundamentals. Number two, pick your language carefully, go deep. There's so many things happening, like always, but I was really surprised how many of these things happening in the landscape of the languages. So I don't know, you heard about Mojo. Apparently, it could be Python replacement. 10,000, 20, whatever, how many thousands faster than Python, whatever. We will leave to the time in the history to judge if that's really true or not. But there's a lot of cool stuff happening. Expander 2, there is Polars, Rust library you can use in Python. There is the languages like Rust and Zig and OCaml and Carbon and a bunch of other stuff. And I know a lot of you are laughing and saying, oh really, I will use system language to do my data stuff. Yeah, startups in Silicon Valley, they use them. They go big on the go and still C and C++, by the way, mostly. They build their AI models which have to run in the car. They have to run in the drone. You won't run your Python in the drone. It will be as low as you can. So think about that one as well. I promised myself I won't put Gen AI, but I did. And I decided to be only once use the squeal or SQL and the Gen AI in the one sentence. And this is cool. If you want to see, you can talk and that will generate actually SQL statement using again LLMs and whatever it is. But some cool stuff. You can take a look at that one. Doesn't matter how much you trust or believe in that one. That's beside the point. The last thing before we go to actually some interesting my own discovery in the industry, solving some big problems was, I don't know what type of compute things you use. By the way, forget AWS. I'm AWS, I love AWS, live and breathe AWS, it's only what I do for a gazillion years, but you have to get comfortable whatever platform you use to go as bare-bone compute service as you can. If you go and jump on some type of informatica tooling, not even about informatica anyway, but any type of tooling, it basically they hide from you a lot of things, and if things works well for you, great. But if things doesn't work anymore as you would like, or you want to maybe optimize something, or you make something faster, tool won't let you to do that most of the time. So that's again, question is, are you how flexible and how free you are to say, okay, you know, maybe my Spark doesn't work, maybe my Hadoop doesn't perform as I wanted, maybe I can go and do something on my own, specific for that use case. Okay, so yeah, I'm not going into discussion here, philosophical, when that makes sense or doesn't make sense, and which talent we have in the company that they can do that versus others cannot. That's a different discussion, but keep that in mind. And as long as you know, number one, which you talk, and number two, which you talk, you will be very flexible and free in your mind. You can go and code this by yourself. I'm showing you here a few examples in our space of AWS. I'm not paid here to advertise any of the service, 10%. We have a manager here, so. And we have a, EC2 as you know, and we have a serverless Lambda, we have a container one, a Fargate, and Kubernetes, and a batch, and so forth. All of those things are really good for specific things which you might do with the data as well. And I will show you after example with AWS Batch. Absolutely love the service. If you want to process petabytes of data really fast, I will use AWS Batch. Especially with Fargate, so I don't need to think about launching computer nodes and everything else. It's kind of serverless system, and you go and deploy gazillion workers in parallel to do your job. And the workflow is all embedded. You don't need to build your own workflow. It's all kind of very simple. You need to learn 3-4 things, and that's it. The whole thing works like a child. So anyway, something for you to, again, think about it in your career. You want to go and learn some more stuff. This is one of the things which I will go. So number one, you have a fundamentals, you know computer science, software engineering. Number two, you know the language which you can use. Here is where to code on and deploy and run. So that's the few things in that one. Okay. I mentioned you some of the things which I want to show you. This is the problems which I was engaged. I usually get deployed on special projects. We don't call them like that, by the way. AWS doesn't have special projects. But I always find a special project within the customers which we are working on or working with. So I'll go a little bit over those examples. Yuri, you know this one. So this is the, so what we do, we customer ours drive the cars. Test cars equipped with radars, sensors, cameras, bunch of different things. And we're talking these top-notch, top-tier car manufacturers. They drive around and they usually equip all the data, get all the data. There's million kilometers driven, hundreds of thousands of hours spending on the road. And they save all the data, and after basically they use for simulation to see how well their machine learning model works, or their new brake system works, or their acceleration, whatever it is. So in order for them to fast test, you have to find specific scenario in those million kilometers driven. And for example, here will be, we always joke as an example it was a rainy day in Copenhagen, which is capital of Denmark. People crossing the road, it was fog, and it was dusk. Do I have that situation in those million kilometers? The only problem here is they have to happen all at the same time. So I might have a raining 5 minutes ago, but now when I'm looking at the moment when actually pedestrians are crossing the road, there was no rain. So that excludes, that doesn't match anymore. So the question is how you do that type of search with 25 petabytes of data, and you have to do that in usually less than a second, usually 100 milliseconds, things like that. So this is something which Sigit and me and a bunch of others worked quite some time to come up with something which would work really, really fast and covers all the cases. So that's one of the things which you can do. Remember, we're talking about number one, number two, number three. That gives you exposure to these type of projects. This is graphical representation of those events and how they can overlap, and we're looking for the overlap of those events. Okay, so there's another case. Most of these buildings here, you can imagine, they're financial buildings. They have companies which do financial calculations, they do trading, they do all kind of different things. Regulators asking them how founded you are, how secure you are for the business. If something happened on the market, would you survive? That's a typical bank question, and they have to run the risk calculation every night. And those 1 billion of calculations happen overnight. And the question is how you do that one really fast. And this is what I mentioned before. Remember that whole, the embarrassingly parallel problems you heard if you work in the kind of Spark and Hadoop, when you kind of swarm and you have a little problem, you partition them in small pieces and you send them to different nodes. This is the type of problem here. So you can achieve huge throughput. We don't care about HPC part, performance necessary, but we care about throughput here. So that's one of the way which I can solve this one here with a service model. But I'm not going into details. I'm not really selling you service, but just kind of understand that there is all kind of different compute capabilities in the cloud or even maybe on-prem that you can do. And the last one, I mentioned that in the beginning here. What you have to do, you have to go deep in your software engineering skills and the data structures algorithms, and there is a lot of cache mapping, and there is a lot of priority queues, and there is a lot of things you have to do, a little bit of graph as well, recursions, things like that. You have to somehow compress your data, that 1 billion of data, somehow to fit in 32 gigabytes of space in the Fargate, to be able to basically compute that in 100 milliseconds. Those are lots of work, days and nights, to come up with an algorithm to solve that problem. We tried, or the team before me, they tried every AWS service which exists. And the fastest they came, I think it was 5 seconds. I came with 50 milliseconds. So I think there is a big difference. The tool doesn't always give you things for free. Sometimes tool really doesn't get where you want to go. And you have to go again to number 1, number 2, and number 3 to solve that problem and to deliver the value to the business. That's it. That was easy. Not midnight yet. Question?
Oh, there you go.
I was fast.
Thank you. The talk was very general, so my question will also be a general. You were speaking about performance and algorithms, and I saw a functional language on your slides, but they are generally known to not be very good in terms of performance, and there is a huge overhead in garbage collection. Why did you put this language, the paper script, on the slides?
I just advertise the
Sorry,
good
how do you
parts.
see the applications of them for high performance computing?
Yeah, so by the way, you're right. My talk wasn't necessary to be fully high performance computing HPC part. It wasn't in the title. My thing was the 3 practices which you should look at that one. I don't know where is your heart. I don't know what you want to be when you grow up. So I gave you Haskell, I gave you OCaml. Oh, by the way, Cambridge, for the students in the beginning computer science course, you know which language they use? The language I never heard before, OCaml. Oxford is using the Haskell as their first programming language. For me it was Pascal, but it's a long time ago. Not Cobol, it was Pascal. So yeah, that's kind of answer. So I didn't necessarily advertise the only. I think Zig is between C and assembler. So if I go with that one, I'll only advertise Zig and nothing else. But Zig might be dead 6 months from now, so I have to be very careful with my choice of languages, new languages. Thank you for your question. Now, you hurt my feelings when you said it was very generic.
Hi, Zoran. Thanks for the amazing presentation, and I really love the idea that being a veteran, you are telling everyone how important the basics are. Because everything, no matter what product you build, ultimately it's classes, functions, data structures, algorithms, operating system, networking, right? My question to you is that there's a very good phrase as we use in software engineering. Everybody can write code, but not everybody can write good code, right? When we are dealing with small or not that much scalable piece of software, right? It's very easy to have that standardized templates. For example, you have to use best engineering practices, solid, dry, Yannick, best domain architecture principles, and integration test, unit test, event-driven architecture, and domain-driven depending upon the requirements. It's very easy to streamline when you're working with small data set, right? Or working with small code base. But as your product grows and you grow in a leadership position as an architect or as a staff engineer, now you're responsible to make sure that your code base has grown to a level that you cannot just refactor everything, and it has become a very spaghetti piece of code. What is your, from your experience, what would you recommend in that leadership position or senior position? What you should make sure that while you are developing and pushing code every day, you're making sure the standard practices are still met as per your growth?
Such a tough question. So I tell you, the one thing I learned, software is never done. Never. And this is what my wife hates about software industry. Because I'm never done. I can go and go till midnight, and maybe that feature looks kind of fine, but there are 17 other features which are waiting for me to refactor to go version 2, version 3, version 4. It goes back to the first principles. Now, there's a test of time. There is some really good stuff happening in the last 10, 20, 30, 40, 50 years. We can go Dixter. I think he's still walking on the hallways in the Stanford. I think my kids saw him a year ago. He's still alive, I think, and walking, or he may recently died. But so anyway, what I'm saying, Dixter we still use his things. Now, I don't know if you know design patterns. So I remember I was sitting 1997 in London. There was a presentation by Gang of Four. I was like a little kid in the candy shop. The Swiss guy, the main Gamma one, or the other guys been there and talking about design patterns. They are still fresh and good and solid and strong today as well. So you have to be very careful to pick the design principles, the way how you refactor, the solid principles, the pence injection. If you use that one, that will stay alive forever. Those are really stable things. Now, Teghan, you show some technologies and everything else which I never heard before. Hopefully they will survive and they'll be doing really well in 2 years from now. But you never heard them again, like many other ones. So be very careful. Don't go quickly with the hype. Don't go quickly and just take some methodology and things without show a lot of usage in the industry. Of course, you might work with some very novel problem. In this case, good luck to you. Hopefully you learn something from your success or failure. That's a problem in the software.
Thank you. Any other questions? Yeah, over here.
I actually just want to request if you can go back to the second slide with the books. I didn't hear.
Oh, sure. By the way, this is just books.
Really fast.
Yeah, I didn't want to spend too much time. So just next one. Okay. So just that you know, my kids both in computer science and both pretty well done with the schooling system and pretty going high. This is what they have to do in my home. Sorry, this one here. There was no discussion. My kid is now a PhD from Stanford, and he says, I really now cherish the moments in high school that I forced him to do that one because his colleagues, PhDs from the top-notch